Jai Hind. Today we'll discuss the concept of graphs. What is a graph? How do we represent graph? This is one topic of third unit of our subject, data structures. So what we are going to cover in this particular lecture is basics about graphs, different definitions that are associated with graphs. Then we will talk about the presentation and we will continue with the graph traversal in the next video, continuous video. So I'm starting with graph basics. What a graph is? We are having two types of data structure. One is linear data structure, another one is non-linear data structure. When we are having some data which can be stored linearly, means the relationship is linear between different elements, different objects, then that can be represented with help of linear data structure. But sometimes we have the relationship which cannot be represented linearly. For example, if I have to find out shortest path from one source to to some destination, so it may be the case that I'm having two paths from one city and the second path via some other city. So we can have connecting roads. So there are maybe two or more ways to go from source to destination. So when we are having two ways, it means the relationship between the source and destination via roads is not linear. If, for example, if I take 0 as my one city, that is my source, and this is my destination. Okay, so I can go via city 1 to 3 or via 4 to 3. So this is not a linear relationship. So this cannot be represented by linear data structures. So when this type of definition requirements are there, then we go for non-linear data structure. Graph is such a linear data structure that can be used to represent this type of relationship. So what is a graph? Graph is a non-linear data structure that is collection of vertices and edges. So it is a set of vertices and set of edges. So in short, we can write G is equal to V comma E. V is my set of vertices and E is my set of edges. So that is the graph. It is the pair V and E. Now what is V? Vertices of graph is the vertex set and EG is the edge set of the graph G. E is the set for this particular graph. So now let us talk about what these edges are, what these vertices are. So let us start with vertex. The set V is a finite non-empty set of vertices. We are having some vertices which we can call nodes also. The set E is set of pair of vertices representing edges. So what is an edge? An edge is a pair. For example, 0, 1. This is one edge. What is 0, 1? 0, 1 means there is one connection between 0 and 1. There is the connecting edge, connecting line. So this is one edge. This edge can be represented by this ordered pair, by this pair of vertices. Okay, so here we are having 0, 1. Later we'll discuss that we can write 1, 0 also because there is no direction. We'll discuss after this. So what is to be taken from this particular slide is the definition of graph. A definition is set of vertices and set of edges. Vertices is the vertex set. Whatever we have in problem, according to that, we decide what will be our vertices. For example, in the problem of shortest path, the cities will be the nodes. Okay. Now, second is our edge set. What is that? Collection of ordered pairs. So this is our takeaway from this particular slide. Now we were talking about edges. V is the set of vertices, that is simply collection of the nodes. Okay, second is our edges. Now let us come to the point that edge may be directed or may not be. So firstly we are taking the directed edges. This is a graph with directed edges. So what we can see here, the direction is from 1 to 2. The direction is from 1 to 2. So when we are having the directed edges, the graph is called directed graph or digraph. A digraph is a graph with directed edges. Edges have directions so that they are represented by arrows. The arrows are telling us what is the direction of this particular edge. When we take one edge, let me take this one, this edge is 1, 2, the pair 1, 2. Okay, so the edge leaves a vertex, it is leaving 1 and it is entering another vertex 2. If I talk about this particular edge, it is leaving 4 and entering 5. Okay, so it is leaving one vertex and entering second. So here we are talking about blue edge, it is leaving 2 and entering 4. This is the direction. Okay, so in this particular graph, if we see, we are having 6 vertices. So what is my V? My V is the set of vertices 1, 2, 3, 4, 5, 6. What are my edges? How many edges are there? Edges is also a set of object. Now what these objects are? What is the set? It contains the pairs. Now here we are having directions. So these are ordered pairs. What we are having here? Direction. So what are ordered pair? This is, let me say, one edge. It is 1, 2. Okay, this is second edge. It is 4 to 1. Another edge 2, 4. Another edge 2 to 2. This is called self loop. Edge is entering the same vertex. It is leaving. This is called self loop. So it is 2 to 2. So we have written this edge, now 2 to 5. 4 to 5, 5 to 4, 6 to 3. So how many we have written? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 3. Okay, self loop is also there. So 7. We are having 1, 2, 3, 4, 5, 6, 7 double edges. Okay, so these are our edges that we are representing with our ordered pairs. For every, we have taken one ordered pair. This is for this, 4, 5 for this, 5, 4 for this, 2, 5 for this, 2, 2 for this, 2, 4 for this, 4, 1 for this and 1, 2 for this. So every edge is one pair. In this particular case, it is ordered pair. Okay. And now how we are representing this? We are representing this with help of the diagram. How do we draw it? How we diagrammatically present a graph which is having a set of vertices and set of edges. The vertices are represented by nodes, by circles with the name, and the edges are represented by the connecting lines. Okay, so this is our directed graph. If I see this one, in this I am having undirected edges. Edges don't have any direction. So what does it mean? It means edge UV is same as edge VU. It means we have edge from 1 to 2 as well as 2 to 1. 1 to 2 and 2 to 1. Same way, if I consider this, I can go from 4 to 5 and 5 to 4. What is undirected graph? Which is having undirected edges. When we are having undirected edges, it means we are having connectivity from 1 to 2 as well as from 2 to 1. Whether you write AB or BA, both are representing the same edge. So ordered pairs are not there. If there is one pair AB, then it is assumed that BA is also there. This is our undirected graph. Now we will study few points about graphs, special graphs. When we are having a graph in which each vertex is connected to each other vertex. So how many vertices are there in this particular graph? 2 vertices A and B, and both are connected to each other. This is called complete graph. We represent it by K2. K for complete, K represent the complete graph, and 2 means the number of vertices. If I talk about this, in this I am having 3 vertices A, B, C. A is connected to BC, B is connected to AC, and same way C is connected to AB both. In this I am having 4 vertices and all are connected to each other. Okay, so this is represented by 4. Now we'll understand one more point here. When I am having this vertex and it is connected to one vertex, that is called how many edges are incident on that, that represent the degree of the vertex, degree. What is degree of B? How many lines are incident on this? That is 1. What is degree of A? 1. In this, how many lines are incident on C? That are 2. So degree is 2, degree is 2, degree is 2. In this, degrees are 3. So we can see that in complete graph, each vertex is having the same degree. For example, in K2, the degree of each vertex is 1. In K3, the degree of each vertex is 2. In K4, the degree of each vertex is 3. So if we are having n vertices, we represent Kn. What is Kn? We are having n vertices in the graph and each vertex is connected to each other vertex. So what does it mean? It means one vertex will be connected to other n minus 1 vertices. What does it mean? It means degree of each vertex is n minus 1. Degree of each vertex is n minus 1. Okay. So now when we are having complete graph and we know that each node is connected to each other node. So can we calculate the total number of edges in the complete graph? In this, the number of edges are 1, here 3, here 1, 2, 3, 4, 5, 6. So can we decide for n? If n number of vertices are there, what will be the number of edges in complete graph? That will be NC2. N into n minus 1 by 2. The total number of edges in the complete graph with n vertices will be n into n minus 1 by 2. That is our possible edges. Now let us talk about one more type of graph, regular graph. What is a regular graph? A regular graph may be complete or may not be. What is the condition? If each vertex has same degree, if each vertex has same degree, all the vertices are of same degree, then it is called regular graph. All the complete graphs are regular graphs. All the complete graphs are regular graph because every node in a complete graph with n vertices has n minus 1 degree. Bipartite graph. Let us consider this undirected graph G with vertices E and E. Vertices V and edges E. So let us see this particular graph. This graph is having 1, 2, 3, 4 vertices. But if we divide into 2 sets, one containing AB and another containing CD, if V can be partitioned into 2 sets, V1 and V2, let me call it V1 and this as V2. If V can be partitioned into 2 sets, V1 and V2, such that each edge UV, either U belongs to V1 and V belongs to V2 or reverse. It means it is from V1 to V2 or V2 to V1. So if I see this particular the 4 vertices has been partitioned into 2 sets. The 4 vertex vertex set is divided into 2 sets, V1 and V2, such that V1 contains AB and V2 contains CD. Now, what is to be checked? Vertex, each edge, if I see each edge is having one endpoint. When I am having this A to B edge, then A and B are called endpoints of this edge. So, if I take this edge, its one endpoint is in V1, another is in V2. Same with this, one in V1, another in V2. Same with this, one endpoint is in one set. So, if I am able to divide such the graphs in this manner, that is called bipartite graph. If a graph can be divided into this form, that is called bipartite graph. Okay. Now, we'll understand the concept, the basic concept of graph, that is adjacency. What is adjacency? Let me consider an edge UV. U is one vertex, V is another vertex. Every edge is a pair of vertices. So, if UV is an edge, it means we can move from U to V. Okay. So, when we can move from U to V, it means vertex V is adjacent to U. Vertex V is adjacent to U because we can go from U to V. There is one edge from U to V. In undirected graph, what is there? The relation is symmetric. If U is adjacent to V, then V is also adjacent to U. But it is not so in directed graphs. If we are having vertex 2 adjacent to 1, see this, we can move from 1 to 2. 1 to 2 we can move, but we cannot move from 2 to 1. There is no directed edge. This is not symmetric, but in undirected graph, this relation is symmetric. If I can go from A to B, then I can also go from B to A. Okay, so here 2 is adjacent to 1, but 1 is not adjacent to 2. Now, how do we represent these in memory? How to implement these? So, there are 2 ways. A graph with set of vertices V and set of edges E can be represented in 2 forms, one using arrays, one using linked list. So, here we are considering graph G, which may be directed or may be undirected. So, let us understand the ways of representation of graphs. So, the 2 common ways are adjacency list and adjacency matrix. Now, let us understand one by one how can we represent this graph in memory. So, we are having 2 ways, adjacency list and adjacency matrix. This we will consider in somewhat detail later, but now let us understand the concept that why 2 types exist, are both important or both are important in some particular context. Okay, so for that we are taking here 2 words, that is sparse and dense. Sparse graph. What is sparse graph? When we are having vertices and edges and number of edges is much less than the number of vertices. Vertices square. If mod of E is much less than the mod of V square. Why we are taking V square? I will just tell on the in the upcoming slides. When this number is very much less, then adjacency list is the preferred case, preferred way of representation. Because what does it mean? It means we are having very few edges. We have to maintain the set of vertices, a big set of vertices, but very few edges are there. So, when we are having few edges, so we will make a list. When our graph is dense, what does it mean? It means we are having a big number of edges present, many connections are there. In that case, we will use the adjacency matrix. We will discuss later what is use of that. Why we are maintaining this difference. So, firstly, I am starting with adjacency list representation. So, what type what is the requirement here? Adjacency list. By name it is clear. We will make a list. What we will make? We will make a list. Now, what is the information in a graph? There are two informations in the graph. One is what are the vertices, and one is what are the edges. So these two informations we have to maintain. Okay. So what does it mean now? Firstly, make a list of vertices. So an array of V list, one for each vertex. We are having adjacency list representation. So there will be a list of arrays. So when we are having a list of arrays, again we are having option. Either we store that in array, or the second option is of linked list. So if I see this particular example, here how many vertices are there? 6. 1, 2, 3, 4, 5, 6 vertices are there, and we are having these edges. Now if you consider the first set is set of vertices. So we are maintaining an array of 6 vertices, 1, 2, 3, 4, 5 and 6. Now what, so we have stored information about vertices. Now what we have to store? We have to store information about edges. So what is an edge? An edge is information of adjacency from one vertex to another. 2 is adjacent to 1. Why 2 is adjacent to 1? Because we can go from 1 to 2. Okay. So what does it mean? For 1, we have to maintain a list which will contain the adjacent vertices. So if I see 2 is adjacent to 1. So in 1's list, I will make space for 2. I'll make a linked list in which I'll store its adjacent vertex. Now I checked all other, I found one more adjacent, that is 4. So 1 is the node, its adjacent nodes are 2 and 4. What does it mean? It means we are having edges 1, 2 and 1, 4 in our graph. 1, 2 and 1, 4. So this information we have stored. So what information we have stored? 1 is the first node of the pair, and 2 and 4 are the second nodes of the pair. So this is representing 2 edges. Now let us come to 2. 2 is the vertex. 5 is adjacent to 2. So we make a node for 5. A list has been maintained for 2 which is containing only 5, because there is only one node. So what information is stored here? That is 2, 5. What information is stored here? 3, 5 and 3, 6. For which we are making the list, that will be the first element of the pair. So 3, 5 and 3, 6. This we can understand 6 to 6. So this is the adjacency list representation of graph. Another is example for undirected graph. When we are having undirected graph, this is our undirected graph. In this we can go from 1 to 2 as well as from 2 to 1. So what is required here? Its directed version is stored. What does it mean? We will store 2 in the list of 1 and 1 in the list of 2. 2 in the list of 1, because when we are having undirected edge, it means we can go from 1 to 2 as well as 2 to 1. 1 is adjacent to 2. So 1 is adjacent to 2 we have stored here, and 2 is adjacent to 1 that we have stored here. This is our adjacency list representation. Adjacency matrix. How do we create adjacency matrix for graph? So adjacency matrix is generally used for dense graphs. What we do in this? We will maintain a matrix. What will be order of matrices? That will be V cross V. If I am having n number of vertices, the size of matrix will be n by n. So we will make an array which is actually two-dimensional array, which is a matrix. Now what will be the entries of matrix? We will make entry 1 if edge exists from I to j. So Aij will be 1 if ij edge exists, otherwise it will be 0. So now let us understand with example. This is our example. If I see here, I am having V cross V matrix. So how many vertices are there? 6. So I am having 6 by 6. This is my 6 by 6 matrix. Now what are the edges? 1 to 2 is one edge. So 1 to 2 is one entry. 1 to 4 is one edge. So 1 to 4 entry is 1. 2 to 5. So for 2 only we are having 5. 3 to 5 and 3 to 6. 4 to 2. 5 to 4. And 6 to 6. So see, only these entries are 1 because edge exists in this pair. So we are having row wise listing and column wise listing of the vertices, and we will make one entry where edge exists and 0 otherwise. As we have seen here, many zeros are there. So it means, what does it mean? Very few edges exist. It is okay for this small number, but when we are having hundreds of numbers, then these zeros, storage of these zeros are just wastage of space. In that case, we generally prefer adjacency list. So in this particular video, we talked about adjacency, about basics of graphs, some important definitions of graphs, and then we talked about the graph representation using matrix and using list. For dense graph, we prefer adjacency matrix. Why? Because when we will have the dense graph, almost all entries will be 1, that is containing information. But when there is sparse graph, it means very few nodes, very few edges are there. What does it mean? Maximum will be zeros. So what we are storing actually, we are storing that edge doesn't exist. Okay, so when edge doesn't exist, then what is use of storing that information? So in that case, what we go for adjacency list, because very few nodes we have to create. So this is all about the basics of graphs. Thank you. Jai Hind.